Hello future engineers, welcome to JT classes. Consent on this side and alumnus of NIT Calicut. In this video we will discuss about quadratic equation. In quadratic also the today's subtopic is analysis of graphs. So suppose if we have the quadratic equation y equals to ax square plus bx plus c. It's a quadratic equation and we know that for the quadratic equation the graph will always be parabolic. Now it can be the upwards parabola and it might be the downwards parabola. It fully depends on the leading coefficient, that is a. So if my a is greater than 0, then the graph will be upwards parabola, and if my a is less than 0, then the graph will be downwards parabola. Then this point we call as the vertex of the graph, that is minus b by 2a comma minus d by 4a. Likewise for this parabola also the vertex will be minus b by 2a and then minus d by 4a. Here d is nothing but b square minus 4ac, that is the discriminant, and a, b are the respectively the leading coefficient and the coefficient of x. Now d is b square minus 4ac and we know that d can be greater than 0, it can be equal to 0 and d can be less than 0. So one by one we will discuss all the three cases. So case number 1, when d is greater than 0. So whenever d is greater than 0, again we have two conditions. The condition 1, d greater than 0 and a greater than 0. The second condition, d greater than 0 and a less than 0. Okay, we know that whenever a is greater than 0, it means it will be upwards parabola, and since d is also greater than 0, it means two distinct real roots. It means that the graph will cut the x-axis at two distinct points. So what can we say? This will be the graph where it cuts the x-axis at two distinct points, that is respectively alpha and beta. So here what can we see? That for some values of x, the graph value is, the function value is negative, and for some value of x, the graph is positive. So if d is greater than 0 and a is greater than 0, then we will get positive function value as well as negative function value. Coming to in the another case, when d is greater than 0 and a less than 0, in that case also the same thing, the only thing that graph will be downwards. Okay, then the next is, what if the d is equal to 0? D equal to 0, it means we do have the equal roots. It means both the roots will be equal. It means it will just touch the x-axis. So if my d is equal to 0 and a greater than 0, it means a greater than 0, it means graph will be upwards, and d equal to 0 means it will just touch the x-axis. So the graph will look like this thing, it will just touch the x-axis. Likewise if a is less than 0, then graph will be downwards, and d equal to 0 means it will only touch. So it will only touch. In the first one, can I say that for one particular value the function value is 0. Other than that, whatever x values you take, function value is always positive. Since this is x-axis and above the x-axis values are positive, it means for all the values functions is positive. So can I say for this one my f of x is greater than equal to 0? It means it's greater than, but at one point it's equal to 0 also. Likewise in the second one we can say that f of x is less than equal to 0. It means at a particular point it's equal to 0 and in the remaining point the function is negative, function value is negative. In the last condition, that is the last category in which the d is less than 0. D less than 0. D less than 0 means no real roots. D less than 0 means no real root. No real root means it won't cut the x-axis. If it won't cut the x-axis, then only two possibilities are there. Either it will be above the x-axis or it will be below the x-axis. So if my a is positive, then the graph will be just above the x-axis, and if my a is negative, then the graph will be below the x-axis. So can I say that for the first one, since d is less than 0, it will always be above the x-axis, and always above x-axis means always the graph will be positive. So can I say f of x is strictly greater than 0, and for the second one f of x is strictly less than 0. Okay, so we are done with analysis of graphs. Now just have one observation. Okay, check out the first point, range of the quadratic. Okay, range means the output. Okay, a greater than 0. Okay, a greater than 0 means graph will be upwards. A greater than 0, graph will look like this. This one if d is greater than 0, if d is equal to 0, and like this if d is less than 0. So if I am asking about the range, can I say range will always be minimum to maximum? And if we see all these three graphs, what can we see? That the minimum always we are getting here. minimum always we are getting here. It means the minimum value we are getting at the vertex, and we know that what is the vertex. Vertex is minus b by 2a comma minus d by 4a. So what is the minimum value? The minimum value is minus d by 4a. So can I say range will be minus d by 4a, that is the minimum. Now for the maximum just check out, this is the minimum, and then it's going up, second also going up, and the last one also it's going up. So what about the maximum not defined. So we'll say range will be minus d by 4a to infinity. Now the second one, when the a is less than 0, a less than 0 means graph will be downwards. Graph downwards means we'll get the maximum value kind of graph. So what can we see? We'll always get the maximum value. This is d greater than 0, then this will be for d equal to 0, and this one will be d less than 0. Minimum is not defined. Why minimum is not defined? Since if you look out at the graph is going down. The graph is fully going down. The graph is going down. It means minimum is not defined, but we do have the upper boundary. So what can we say? And what is that upper boundary? If you get nothing else but the vertex itself, that is minus b by 2a comma minus d by 4a. So the range will be minus infinity to minus d by 4a. This was about the range. Now coming to the second point. Now what is the second point? The second point is ax square plus bx plus c greater than 0. The function will be greater than 0, strictly greater than 0 for all x. So what will be the condition? If graph is strictly greater than 0 for all x, it means it will be like this. Then only it will be strictly greater than 0. And now what is this condition? This condition is a greater than 0 and d lesser than 0. Now coming to the second condition. What is the second observation? Ax square plus bx plus c negative for all x. It means my function will be strictly less than 0 for all x if we have this condition. It means a negative and d also negative. So basically we have seen three cases. That first one is d greater than 0, second one is d equal to 0, and the third one is d less than 0. Both all the three cases we have checked for both the a values, when a is positive, when a negative, a positive, a negative, and here also a positive, a negative. What we have seen, if a is positive, graph upwards, a negative, downwards. That only we have seen. Okay, we have observed one more thing, that if my d is equal to 0, then my function is greater than or equal to 0, or my function is less than or equal to 0 based on a. In case d is less than 0, then my function is either strictly greater than 0 or my function is strictly less than 0. That for all x values. This also for all x values. D greater than 0, it means function can take negative values, positive values, 0, all the values the function can take. Okay, so now we'll just do one PYQ, that is a 2021 PYQ. Okay, check out. What do we have? We have that the integer k for which the inequality greater than 0 is valid for every x in R. Okay, so what is the key point? Every x in R. Every x in R means for all x. So what they are saying? They are saying that x square minus 2 times 3k minus 1 plus 8k square minus 7 is strictly greater than 0 for all x in R. And we know that if my function is strictly greater than 0 for all x, it means what? It means that my a is greater than 0 and d is less than 0. A is greater than 0 and d is less than 0. Now check out a. A is 1, that is already greater than 0. Now check out d. D should be less than 0. Less than 0 means what can we say? We'll write d is nothing but b square minus 4ac. So what can we write? We can write that b square means 4 3k minus 1 whole square minus 4ac. So 8k square minus 7 less than 0. Now just simplify it. So if we simplify it, we'll get 4 9k square, then minus 6k plus 1 minus 32k square plus 28 less than 0. So if we simplify it, we'll get 4k square minus 24k plus 32 less than 0, which is nothing but k square minus 6k plus 8 less than 0. From here we'll get k minus 4, k minus 2 less than 0. So from here what we'll get? We'll get that k is in between 2 to 4. So we'll get k is in between 2 to 4. Now in the question it was given that k is an integer. In the question only it was given that k is integer. Now k is integer and k is in between 2 to 4. It means k will be 3. So here the answer will be k equals to 3. That is option A. Thank you.